Hello, my name is Wieslaw Woszczyk. I am a professor at the Faculty of Music, currently Schulich School of Music at McGill University in Montreal, Canada. And I had the pleasure of being the principal investigator on a 4-year project funded by Valorisation Recherche Québec to the tune of $2.2 million, which just ended. The project was called Real-Time Communication of High-Resolution Multisensory Content Using Broadband Networks. And this project involved 6 co-PIs, 6 researchers from University of Sherbrooke and from McGill University. And our objective was to develop technology allowing artists, musicians, dancers, poets, anyone to be able to communicate with a distant participant using full sensory capability. And we decided that in order to have a sense of presence of a distant participant in my own space, I would like to have not only visual and auditory presence of that person, but also to feel the vibration and have a tactile sensation, haptic sensation of whatever is going on at a distant location. We had, as I mentioned, 6 task leaders in our team. One of the task leaders was Professor Jeremy Cooperstock, who was in charge of developing the transport system for transporting media through network systems. Our main objective was to reduce the latency of transmission. We know that latency kills interactivity, that you cannot wait for a response of the other person. You are expecting to receive it immediately. John Roston was the other task leader who was responsible for developing video technology and adapting existing systems, including high-definition video, to our needs. Our third partner in research was Professor Daniel Levitin from the Faculty of Science and Psychology Department here at McGill. He measured to what extent we would allow asynchrony between these individual streams, and also measured other more advanced and deeper functions of the brain and perception, as well as the emotional transmission and state of the participants, to what extent that communication would be totally transparent, and to what extent technology would be not felt. The presence of technology would not be felt by the participants, and they could simply intuitively, interact with each other. Our fourth participant was Professor Alain Berry from Gauss Group Acoustic of University of Sherbrooke, and Professor Alain Berry was developing an advanced system for wavefield synthesis using adaptive correction of wave field produced by the loudspeaker system. So his function was to see if wavefield synthesis could be improved as a method of rendering sound field around the participants in this network communication. Our fifth member of the team was Professor William Martins from the Schulich School of Music here, who was in charge of the haptic and vibration component of this research. He developed a system for capturing vibration and optimizing vibration as a counterpart of sonic communication. Finally, my role was not only as a scientific director and the chair of the management group for this project, but also as my task was to look after the audio needs for this project, to provide appropriate capturing and transmission and then reproduction of sound with minimum latency. And we have made major improvements together with Dr. Jonas Brash, who now is at RPI as our research associate. We were able to not only capture the sound, but also to control it in space in our multi-channel loudspeaker laboratory that consisted of 24 loudspeakers surrounding the communication space, both above and around, and we were able to use that system and to reproduce completely the space that exists far away. Over the course of this project, we also had jam sessions with Stanford University, with Center for Computer Music and Acoustics, there with Professor Chris Chafe and his group, and we also performed remotely at the University of California in San Francisco at Genentech Auditorium using multi-channel 1-bit audio transmission, DSD, direct stream digital, that is used in Super Audio CD, and a wonderful system from Meyer Sound Laboratories. And we were able to present Red Path Hall and our students to remote audiences. The detail of presentation was astonishing. We could hear the airplane passing over Red Path Hall right there, standing in Genentech Auditorium in San Francisco. So these types of applications, where we foresee with network capabilities increasing, the bandwidth increasing, being more accessible, that we will be able to use our technology not only to transmit music and performance of different kinds, to communicate, but also to share stories, to share discussions, to simply feel closer to each other. The mandate of CIRMMT obviously supports that type of research, as it is an interdisciplinary research that involves support of technology for the arts, as well as feedback from the arts to the development of a better technology. So we are very happy that CIRMMT is here at the Faculty of Music. So it is very fortunate that through the actions of Canada's policies in research by creating Canada Foundation for Innovation, and similar actions of Quebec by creating VRQ, FQRSC, and other agencies, that we had this opportunity to move Canada forward in being at the leading front and leading edge of development in media technologies and in studies of music making, music capturing, preservation, and enjoyment of music.